Logical implication. Logical implication, the statement written as if P then Q, or in symbolic P error Q, which is we can read as P implies Q, also meaning as Q implies by P. Next, what is P and what is Q? P we call it as antecedent or hypothesis, and Q we call it as consequence or conclusion. The table shows that how to show that the statement is true. First, if both P and Q is false, then the statement is true. If P is false, then Q is true, then the statement is true. If P is true and Q is false, then the statement is false. Next, and last, if both are true, then the statement is also true. Next, another way is to read logical implication. Okay, we know that the statement written as if P then Q. Other ways is 1. Q if P. Second, P is sufficient for Q, also mean as P is a sufficient condition for Q. Next is P only if Q. Q is a necessary condition for P. Q whenever P. And last, Q from P.
Okay, next, content. Okay, we will go through on negation of a conditional statement first. So, what is negation? Basically, we call the negation as not, which means the truth value of the negation is always the opposite to the truth value of its original.
Okay, now let's consider this following statement. If we decide to go to the library, then I will go with you. First thing first, we have to determine which one is P and which one is Q. Where P is hypothesis and Q is conclusion. Okay, to determine how we might rephrase the negotiation of the statement, we must construct the truth table shown below. After we have constructed the truth table, then we can see that the negation not P implies to Q is logically equivalent to the conjunction P and not Q. So now we can rephrase the negation of the statement. If we decide to go to the library, then I will go with you, as you decide to go to the library but I didn't go with you. Next, we will continue to related conditional. In related conditional, there are three important forms that related to P implies Q that will be introduced, which are the converse, the inverse, and the contrapositive. So, what is the converse? The converse is when we interchanging hypothesis and conclusion. The inverse is negating the hypothesis and the conclusion, while the contrapositive is negating both the hypothesis and the conclusion. Okay, to make it more clear, I have to change it into the symbol. Okay, this is the conditional statement. P implies the Q. So after we converse it, we will get P implies. After we converse it, we will get Q implies to P. And the inverse, we will get not P implies to not Q. While the contrapositive, we will get not Q implies to not P. Okay, this is when we change it into the words. Okay, conditional statement, say, if you stay, then I leave. The converse, we will get if I leave, then you stay. The inverse, we will get if you do not stay, then I do not leave. And the contrapositive, we will get if I do not leave, then you do not stay.
Okay, let's continue with example number 1. Consider the implication. If I'm happy today and wake up early, then I go for cycling. First, we need to identify all the primitive statements. P, I am happy today. Q, I wake up early. And R, I go for cycling. We have 3 questions from the example 1, which is A, define the antecedent and consequent. B, state the contrapositive of inverse. And the last one is C, write the negation. Okay, question A, define the antecedent, hypothesis and the consequent conclusion. Okay, we find that the antecedent is P and Q. I am happy today and wake up early, while the consequent is R, I go for cycling. Antecedent also known as hypothesis and the consequent known as conclusion. Okay, the next question. B, state the contrapositive of inverse. The given statement is P and Q implies R. To get the contrapositive of inverse, we need to find the inverse of statement first. So, we get the inverse is not P and Q implies not R because it obtained by negating the antecedent and the consequent. After get the inverse, we can find the contrapositive of inverse. Okay. It obtained by both negating the antecedent and the consequent and by interchanging them. So, the contrapositive of inverse is not R implies not P and Q. The last one is C, write the negation. The statement is P and Q implies R. To write the negation, we need to put the negation symbol in front of the statement. It will be not close bracket P and Q implies R. Okay, next, not close bracket not P and Q or R. It is from the definition of implication. So the final answer is P and Q and not R. The conclusion, I am happy today and I wake up early, but I not go for cycling.
First of all, thank you Anis Shafika for the explanation of example 1. Today, I would like to show how to answer this question. Example 2. Given the statement, if Sally has enough pineapple, then she is either bake a pineapple cake or pineapple pie. A. Identify all the primitive statement. B. Write the negation of the given statement. For the first question, identify all the primitive statements. Sally has enough pineapple. We label it as P. Next, she is baking a pineapple cake. First, we need to rephrase the sentence into Sally bakes a pineapple cake and we label it as Q. Lastly, Sally bakes a pineapple pie and we label it as R. Just a reminder, when we identify the primitive statements, we must label it with lowercase letter. Next, example 2B. Write the negation of the given statements. First of all, we need to turn the given statement into symbolic. So, P implies parenthesis Q or R. Next, the question asks us to negate the statement. By using a definition of negation, so, not open bracket P implies parenthesis Q or R, close bracket. Next, by using a definition of implication, we turn the equation inside the bracket into symbolic. So, not open bracket not P or parenthesis Q or R, close bracket. By using De Morgan's law, we need to expand the equation. Not P or not Q or R. not P will turn into P by using law of double negation. By using De Morgan's law, we need to expand not Q or R into not Q and not R. So, the answer for this question is P and parenthesis not Q and not R. Negation of the statement is Sally has enough pineapple and either she is not baked pineapple cake and pineapple type.
Okay, now let's continue to the example 3, which is the past year question of March 2017. The instruction: for each of the following statements, fill in the blank with the word converse, inverse or contrapositive so that the result is a true statement. Okay, for the first question, the inverse of what of negate P implies Q is the converse of Q implies negate P. Okay, in this question, we need to solve the statement at the back, which is the converse of Q implies negate P. We will get negate P implies Q. And the statement at the back must be same with the in front of the statement. Which is, we will continue to the inverse of negate P implies Q, and we will get P implies negate Q. And the question asks the inverse of what we will get negate Q implies P, so that the answer is the converse of P implies negate Q, and we will get negate Q implies P. Okay, next, for the question 2, the inverse of what of R implies S is the converse of negate S implies negate R. We need to solve at the back statement, which is the converse of negate S implies negate R, and we will get negate R implies negate S. Like I said before, at the back statement must to be same with the in front statement. So we continue to the converse of negate R implies negate S, and we will get negate S implies negate R. So that what is the way to get R implies S? So the answer is the contrapositive of negate S implies negate R, and we will get R implies S. Okay, next, the third question. The inverse of the converse of P implies Q is the what of P implies Q. In this question, we need to start with the converse of P implies Q, and we will get Q implies P. After that, we need to inverse of P implies Q, and we will get negate Q implies negate P. Negate Q implies negate P must be same with the answer of the back statement, which is the answer is the contrapositive of negate Q implies negate P, and we will get P implies Q. Okay, for the last question, the converse of the contrapositive of Q implies P is the what of Q implies P. In this question, we need to start with the contrapositive of Q implies P, and we will get negate P implies negate Q. After that, converse of negate P implies negate Q, we will get negate Q implies negate P. The answer of negate Q implies negate P must be the same with the answer of back statement, so that we will get the answer is inverse of negate Q implies negate P, and we will get Q implies P.
Okay, for the final content is the conclusion. What can we conclude from the explanation and the example from before? First, what we can when we can say that they are logically implies. When both P and Q is false, then the statement is true. When both statement is true, then the statement is also true. When P is false, then Q is true, then the RUSNANI statement is true. Second is what are the three related conditional? Yeah, first, converse, inverse, and contrapositive. Okay, as explained before. Okay, and third, when we can say that they are not logically implies, or when P is true and Q is false, then we can say that they are not logically implies.